Morning. This is the pre-calc assignment. Today you're going to be doing numbers 3 through 6 on that packet that I gave you, continuity numbers 3 through 6. So what you're going to do is you're going to determine if a function is continuous at a given x value. So in this case, we have our x value as x equals negative 3, and this is our function f of x equals x plus 3 over x squared plus 4x plus 3. So you're going to determine if it's continuous at this value, and if it is continuous, just write continuous. If it is not continuous, you're going to write what type of discontinuity is it. So the way we're going to do that is we're going to take our value and we're going to plug it in at first. So that should be an f of negative 3 equals, I got negative 3 plus 3 over negative 3 squared. Sorry about how sloppy it is. Time plus 4 times negative 3 plus 3. And what I get is negative 3 plus 3 on top is 0 over. I get negative 9 minus 12, positive 9, I'm sorry, what am I doing? Sorry, got distracted. Negative 3 squared is positive 9. Positive 9 minus 12 plus 3. So if you notice, I get 9 minus 12 is negative 3, plus 3 is 0. So I'm going to get 0 over 0. So that tells me right there it is not continuous. I have 0 in my denominator. So what it's going to tell me is what type of discontinuity is it. The way I do that is I have to factor the bottom. All right, I'm going to factor the bottom. And so if you recall, this is x. So if you recall how to factor, you might want to watch a video, but this is x plus 3, x plus 1. So I can rewrite this function, f of x, as x plus 3 over x plus 3 times x plus 1. So I am assuming that you remember how to factor. If you're not, if you're struggling with it, reach out to me. We can talk about it. But also there is plenty of YouTube videos how to factor polynomials, trinomials particularly. So right now, if you notice that on top I have x plus 3 and I have it on bottom. So since they're both on top and bottom, I can cancel it out. There's a 1 left over on top. So then my function is 1 over x plus 1. That's a plus sign. So what I have is a hole, right? Because I can remove it. A hole is called a removable discontinuity. So what we just did was we have a removable discontinuity at x equals negative 3. So that's my answer. Obviously, it is not continuous because I have a removable discontinuity at x equals 3. Excuse me. I'm going to go ahead and do another example with you. So in this case, we're going to examine this function at x equals 1. Again, I'm going to plug in my value and see what happens. If I get a value, it's continuous and I don't have to go any further. So I'm going to do f of 1 equals 1 plus 1 over 1 squared minus 1 plus 2. So 1 plus 1 is 2 over 1 squared is 1 minus 1 plus 2. And I get 2 over, well, 1 minus 1 cancels out, so 2 over 2, which is 1. So, since I got a value, I'm going to say f of x is continuous at x equals 1. And that's my answer. F of x is continuous at x equals 1. It's continuous. I don't have to mess around. I can move on to the next problem. Again, you can pause this and speed it up, slow it down as much as you need to. Example 3. So notice they're giving me two different values now. X equals -1 and x equals 1. So I'm going to test both. Now, if you notice, if I were to put -1 in for x squared, I'm going to get 0 on bottom. -1 squared is 1. 1 minus 1 is 0. If I plugged in 1, 1 squared is 1. 1 minus 1 is 0. So I already know just by looking at it that I'm going to have discontinuity at both of those points because I'm getting 0 in the denominator. So now what I have to do is I have to understand which type of discontinuity is it. Is it a removable discontinuity, or is it a asymptote, which would be an infinite discontinuity? So I can factor this bottom as, remember, x squared is x times x, but then -1 is 1 and -1. So that factors as x plus 1 times x minus 1. Right? So what we're left off with is f of x equals x plus 1 on top over x plus 1 times x minus 1. I'm going to go ahead and change my color to show you this. But I have x plus 1 on top, x plus 1 on bottom, so I cancel those out, and I'm left with 1 over x minus 1. And this is going to tell me what type of continuity. So if I were to put in -1, then the x plus 1's cancel, they become 0. So at x equals -1, f of at x equals -1, it's a removable discontinuity because I'm removing that issue out, right? By canceling out, because -1 is when I put -1 in there, that's what's going to give me my 0 in the bottom. So it's a removable discontinuity at x equals -1. And then notice that left me off with 1 over x minus 1. Well, I can't remove that. I can't remove the x minus 1. So where at x equals -1, there's going to be a hole in the graph. At x equals +1, there's actually going to be a vertical asymptote. So what we call that's an infinite discontinuity. Discontinuity at x equals +1. I got to learn how to spell discontinuity. So those are my answers. I have a removable discontinuity at x equals -1 and an infinite discontinuity at x equals +1. Removable because I can cancel them out. Infinite discontinuity because I can't cancel it out. And then we also have these piecewise functions. So in order to determine if this is continuous or not at x equals 2, I'm just going to plug in the value in both of these. If the value is the same, we say it's continuous. If the value is not, we say it's a jump discontinuity. So notice, I'm going to plug 2 in here. So 3 times 2 plus 1 is 6 plus 1, which is 7. So on the left side, where x is less than 2, I'm approaching 7 on my y-axis. Now I'm going to do the right side, and the right side is where x is greater than 2. So that's going to get plugged in to that equation. So I'm still working with 2. I want to see if they're the same value. So 2 times 2 squared plus 2 minus 4. So I get 2 times 4 plus 2 minus 4. So I get 8 plus 2 minus 4. 8 plus 2 is 10. 10 minus 4 is 6. So if you notice, 7 does not equal 6. So what that tells me is my function has a jump discontinuity at x equals 2. Because they don't equal each other, I have a jump discontinuity. That's my answer. I'll circle that in green. But again, if they did equal each other, then it would be continuous. So if I did all this work here and I got my answer to be 7 and both 7 equals 7, then I would say it's continuous. So again, today, Gabby, what you're doing is you're doing numbers 3 through 6 on that worksheet. Any questions, reach out via Remind. Have a good one.